Welcome back, all of you hard-working chemists. Today, we will be covering day 4 of our Unit 8 notes. We're going to be predicting products of single replacement reactions. So, if you remember back to when we first talked about our types of reactions, we discussed that single replacement reactions involve one element replacing another element in a compound. So, we are essentially switching partners. Our elements are switching partners. When they switch partners, we have to keep in mind that positives must always pair with a negative. So a cation, a positively charged ion, must always pair with an anion, a negatively charged ion. So please do keep that in mind as we go through our examples today. Another thing you want to keep in mind is how to identify a single replacement reaction. So when you are looking at a problem and you are given some reactants on your left side of your equation, you are going to look for a compound and an element as your reactants. If you see a compound and an element as your reactants, you need to be thinking single replacement reaction. And then you are going to figure out the products from there. The last thing I want to note before we start our examples down here are that when you have a single replacement reaction, when you identify your compound and your element in your reactants, not all of the reactions you are given are going to actually occur. We are going to use this thing called the activity series to help us figure out if the reaction will actually occur. The activity series, the chart, is right here on your notes. It is also on your periodic table of elements, the formula chart that you receive with every quiz and test. So you do not need to memorize this. You will always have this resource during your assessment. So we are going to use this activity series to help us know if the reaction is going to occur, because if the single element is actually higher on the activity series, it is going to replace the substance lower on the activity series. So down here, for example, we have a compound, calcium chloride, and potassium. So a compound and an element as our reactants tell me I need to be thinking single replacement. And in order to determine if this is actually going to happen, if this reaction will occur, I'm going to take a look at my activity series. I see that my single element, potassium, is higher than the element in my compound, calcium, the other element. Since potassium is higher than calcium on my activity series, it is going to replace calcium. So when we go to predict our products, we are going to need to consider the charges on our ions in order to write those products. So I would advise you to perhaps write the charges of your ions above your elements before you go ahead and write your products. Calcium is a group 2 element, so it is going to have a charge of +2. Chlorine is a group 17 element, so it's going to have a charge of -1. And potassium, likewise, is a group 1 element, so it is going to have that +1 charge. So now that we have all of our charges written out for our ions, and we know that potassium is going to replace calcium, we can write our products. So I'm going to write potassium chloride as my product because I know that I will need 1 potassium and 1 chlorine with a charge of -1 to cancel each other out and make a neutral compound, potassium chloride. And all that's left for me to do now is write calcium by itself. Potassium kicked calcium out of that spot, and now we have potassium chloride and calcium. So we have now written our products. This is our skeleton equation. It is not balanced yet. So we're going to go ahead and balance it to make sure we have our final equation nice and ready to go. So I'm going to use the box method. If you would like to use another method, you are more than welcome to do so. But I found a lot of you are using the box method, so I'm going to continue to use that on this video. So right here I have 1 calcium and 2 chlorine ions in this compound. I have potassium and chlorine, and calcium right there. I'm going to treat my arrow as a equal sign. And I want to make sure I have the same number of atoms of each element on both sides of my equation. So I'm going to add a box over here to increase my number of chlorine on both sides to 2. Remember, when I add another box, I want to make sure I'm including everything that I had in my first box in that next box. The calcium and the chlorine are a package deal in this case. We cannot separate them. So since I have added this box and increased my number of chlorine, I have also increased my number of potassium. So I'm going to come over here to the other side of my equation and add another box. Now I have 2 potassium on each side, 2 chlorine on each side, and 1 calcium on each side. The final thing I need to do is write my coefficients at the beginning of each of my elements or compounds. That matches the number of boxes I drew. So I drew 1 box for calcium chloride, 2 boxes for potassium, 2 boxes for potassium chloride, and 1 box for calcium. So that is my final balanced single replacement equation. Moving on to example 2, we are given the compound barium hydroxide and the element zinc. So again, we see that we have this compound and this element as our reactant, so we need to be thinking single replacement. But before we can move on and write our products, we need to actually determine whether or not this reaction is going to occur. So I'm going to come over to my activity series again, and I'm going to identify zinc and barium's positions over here. So I see zinc right here, and I see barium up here. So in this case, zinc is actually below barium on the activity series. If our element, our single element, is below the other element on our activity series, it is not going to replace that element. In other words, no reaction will occur. So we're going to write NR for no reaction. And just to make sure we're really clear about why this reaction is not happening, I'm going to write a little explanation down here. Zinc is lower on the activity series than barium. So the reaction does not occur. That's why we wrote NR, no reaction. If your single element is lower on the activity series than your other metal over here, that reaction does not occur. So don't do all that extra work. Don't write out products for a reaction that is not going to happen. You can just write NR. And if it asks you to explain why, you can write something similar to what I just wrote there. So those were our first 2 examples. We don't need to worry about balancing since the reaction did not occur. We're going to move on to example 3, which has our reactants written out in words. So when we are given this word equation like this, what I would do is very similar to what we did up in example 1. I want to make sure I'm writing my charges for my ions above each ion, so that way I know how to write the final formula of my compound. Right here I have magnesium. Magnesium is a group 2 element. It is going to have, therefore, a +2 charge. And we're also given nitrate. If you see nitrate, those 8 and 8 endings, you need to be thinking polyatomic ion. Go over to the back of your periodic table, find that polyatomic ion list, and find that nitrate is NO3 negative 1. So I'm going to make a note up here that nitrate is NO3 with a negative 1 charge. We're told it reacts with chromium. Chromium is a transition metal without a set charge. We don't necessarily know its charge. We're just going to leave it right there for now, but I did want to make a note of the symbol for chromium. So I'm going to write out magnesium nitrate. I'm going to make sure my charges cancel. So to get my neutral compound, I'm going to need 1 magnesium and 2 nitrate, since I wrote that negative 1 twice. So there is magnesium nitrate. We are told it's going to react with chromium to produce something. Now we don't know if it's actually going to react yet. So again, we are going to go over to our activity series. We're going to locate chromium. Chromium is right here. I'm going to underline our elements this time so we can keep track of which ones we're looking at the time. And magnesium is up here. So again, we have another case where our element, our single element, is lower on our activity series than the other element. So again, we can write NR because no reaction will take place. Chromium does not have what it takes to kick magnesium out of that spot, and so no reaction will occur. Again, we don't have to balance since there's no reaction happening. There's nothing for us to balance on our right side and our left side. So we're going to go ahead and move on to example 4. Another word equation here. I'm going to do the same thing I did up here. I'm going to write out my ions and their charges. In this case, we have a transition metal copper. So this does not have a set charge, but luckily we have this Roman numeral 2 here to tell us that this copper has a +2 charge. And we also have oxide, which refers to oxygen. So oxygen is a group 16 element. It's going to have a -2 charge. This copper oxide, this copper 2 oxide, is going to react with aluminum, which is a group 13 metal. So it's going to have a +3 charge to produce something. So again, we're going to write out the formula for our copper 2 oxide. This one is really nice because the +2 and the -2 cancel each other out, letting us know that this compound's formula is going to need 1 copper and 1 oxygen. And then we have aluminum by itself. So we are going to go ahead and make sure the light stays on. Okay. We are going to go ahead and look at our activity series and see if aluminum will replace copper. So I see aluminum right here. I'm going to put a little dot next to it so I can make note that that is aluminum right there. And copper is down here. So in this case, our single element is higher on the activity series. Aluminum is higher than copper. So it will replace the substance lower on the activity series. Aluminum does have what it takes to kick copper out of that spot. But when aluminum goes to partner up with oxygen, we are going to consider our charges of our ions in order to write our final compound. We're going to have aluminum and oxygen. And I know that my aluminum has a +3 charge, and my oxygen has a -2 charge. So I'm going to need 2 aluminum and 3 oxygen to make a neutral compound. I also want you to note that I wrote aluminum first when I replaced copper. This is because we always write our cations first. When we have an ionic compound, we're always going to write our cations, our positively charged ions, first. And that is just what I did here for aluminum oxide. Now that aluminum has replaced copper, copper is by itself, and we have determined our products. So the final thing we need to do is balance our equation. So I'm going to use a little bit different method than the box method for this one. I'm going to instead write copper, oxygen, and aluminum underneath my arrow and balance on both sides. So I see I have 1 copper on my left side, 1 oxygen on my left side, and 1 aluminum on my left side. On the right side, I have 1 copper as well, 3 oxygen, and 2 aluminum. So I want to make sure I'm equal on both sides. So I'm going to go ahead and put a 3 in front of my copper oxide to increase my number of oxygen on my left side to 3. But in doing that, I have also increased the number of copper to 3. So I'm going to come over to my right side and put this 3 in front of my copper. Now my copper are equal on both sides. I still need to take care of aluminum though. I see I have 2 on my right side and only 1 on my left side. So I'm going to go and put a 2 in front of my aluminum over here. That will get me to 2 aluminum. If you would like to put a 1 in front of aluminum oxide, you are more than welcome to do so. You don't need it though. So there is our final balanced equation, and we have completed our single replacement predicting products notes. So you can go ahead and flip to the back page, the next page of your notes, page 11, and work on the day 4 practice problems. These will help you get much better at predicting your products of single replacement and prepare you for your quiz. So please let us know if you have any questions, and good luck!